Hello everyone, my name is Ashish and welcome to the Xadmin channel. So today we are going to discuss the interview question and answer asked in the core Java for a software developer profile in TCS. So like recently I have appeared for the software developer profile in the TCS. So today we will discuss all the questions which are asked to me. So let's move ahead and let's see the first question. So first question was like, tell me something about yourself and about your project in which you are currently working. So basically you have to give a brief introduction of yourself, and like mostly you have to talk about your project, that what is the name of your project and what is your project is doing, and what are the technical stacks you have used in your project, and also you can like define your roles and responsibilities in your like application or the project. So the next question was like, what is the role of yours in this project? So basically in this you have to define your responsibilities and the work which you are doing in this like the project. So basically as a developer you're doing the development, so which task you have recently taken up, and also you can discuss your daily like workflow, right? So the next question was like, what are the technologies you are using in this current project? So basically you have to tell the name of the technologies which are used in your current project, but you should remember one point, that you can only mention the technologies which are like known to you and you have a very like you have like a very good knowledge on those topic. Okay, so you can skip some of the topics or technologies which in which you are not have a good knowledge, right? So as per according to me you can like define all the technologies which are like known to you, and also you have a good command on those, right? So next question was like, what is a stream API? So this is from the Java 8. Okay. So he asked me that which Java version you are using. So I said Java 8. So the next question came like, what is Stream API? So basically, Stream is from the Java.util.stream package, and it has came from Java 8. So Stream is used to process the collection of objects, right? So it is basically used to process the data which is stored in a collection. So it is a sequence of data that support various methods which will be pipelined to produce the desired result. Actually, in a stream API, there is a pipeline. So pipeline means there will be uh, like number of functions or the methods are used to produce the desired like result, and the stream has certain own methods with their own purpose, and we can use those methods, okay, to produce the desired result. And stream is like not storing any element, right? So this is one point, that in collection we store the element, but in stream it does not store any element. It's only process the data which is stored already in a collection. So the operation in a so here the operations is a functional in nature, and it does not modify the source data if the operation is done, right? So with the stream API, it does not modify your source data. So source data can be, the data can be stored in a file, or the data can be stored in any type of collections or array or the network, right? So it does not modify it. It only work on that data and try to produce the desired result. So this is about the stream API which came under Java 8 version. So the next question he asked, like, do you know that a stream is lazy? So your answers would be yes, stream is lazy, and the reason is that in the stream API there are two type of, yeah. So like in Stream API, there are like two type of the process are going on. First is the intermediate operation, and the second is the terminal operation. Okay. So let's understand this by an example. Here I have given one example. So here you can see that this is an employee class which is having one like member variable with the age. So here I want to print or filter all the employees having the age greater than 30. So how we can do with the stream API? So first of all, let's say that all these employee objects are stored in a list. So this is the list.stream. So we have to convert this list to the stream by calling the stream method, and then stream dot filter. So filter is method coming from the stream. So filter method is used to do the filtering with the certain condition, right? So here we can use filter method and then emp and the arrow key. So here I am using a lambda expression, and here I am doing system.out.println and trying to print employee object or information here, and then returning emp dot get age greater than 30. So here I am putting some condition, right? And this, so this is called as intermediate operation. Okay, so stream operations are divided into two parts: first intermediate and second terminal. So till here it is called as intermediate operation, and after that, so after like filtering the employee object with the age like greater than 30, now I'm trying to iterate it and try to display all the info. So for that, here I am use for each method. And then here again, I'm using lambda expression to print out the employee info, which are greater than age 30, right? So this is called as terminal operation. So last part is known as like from for each, it is called as terminal operation. So here stream is lazy. What does this mean? That if we will not use this terminal operation, so till here it is not going to execute, or it is not going to, like here you can see that I'm using system.out.println, but it is not going to print out the employee because stream is lazy. It means that we have to define the terminal operation also. If we will not define this terminal operation, then stream will not execute and it will not do the filtering part, right? Until or unless we will not deploy means add this terminal operation, right? So here if I remove this terminal operation and run our program with the intermediate operation only, then in console no print. So in console we will not get any print and it will not get executed. To execute this stream we have to add this terminal operation. So this, so that's why the stream is lazy. So in this way you have to explain, or also you can give a proper example so that the interview will come to know that you have proper knowledge about this. Okay, so yeah, so like always you have to mention that like a stream has like two operations: first intermediate and the second terminal. So without terminal, uh, like the stream will not get executed, right? So the next question was like how many type of memory in JVM. So here you have to discuss about the memory. Okay, so I have like I have here, yeah. So here we are going to discuss in a deep manner about the memories and also what are stored on those memory. So basically, the JVM has the five type of memory. First is the method area, second is the heap area, third is the stack area, fourth is PC register, fifth is native method stack. So basically, this is one of the important questions which come in your interview of core Java. Okay, so first is like method area. So let's discuss the method area. So for every JVM, one method area will be available or will be created by the JVM. So method area will be created at a time of a JVM startup. So when we will start the JVM, so it will create one method area. So here the static variables will be stored. So actually in method area, the static variable will be stored, and the constant pool of a class will be stored inside the method area. So constant pool, I believe you know, it is a special like area for storing the string reference, right? So those like constant pool of a class will be stored here, yeah, inside this method area. and the static variables will be stored in this like method area, and the method area can be accessed by multiple threads simultaneously, so it is not thread safe. So basically method area is not a thread safe here. So like it can be accessed by a multiple threads simultaneously, right? So this is all about method area. Now the second memory is like heap area. So for every JVM, one heap area is available. So heap area will be created at the time of the JVM startup. And here inside heap area, the object and the corresponding instance variable will be stored in heap area. So all the object and the instance variables will be stored in heap area. So every array in Java is also an object. So that array object will be also stored in heap area. And the heap area can be accessed by multiple thread, because the data stored in heap area is not a thread safe, and the heap are need not to be continuous memory, and also the heap does not take any continuous okay. So this is all about the heap area. Now let's discuss the third like memory, that is a stack area. So stack area is defined for every thread. So JVM will create a separate stack for every thread at the time of the thread creation. Let's say a thread is created, so a JVM will allocate a separate stack area for that particular thread. Now let's see what is stored in that stack area. So each and every method call performed by that thread will be stored in a stack, including local variables also. So basically a thread will call a method, right? So that method information will be stored on that stack area. And also the local variables, you know that local variables are defined inside a method or certain okay. So that local variables are also stored in a stack area. So after completing that method call, so the stack area will be removed, right? So let's say that a thread is created, so JVM will also create a stack area for that particular thread and will assign to it. So thread work is to call a certain method or to do certain operations. So all those calling of that method info will be stored in this stack area, and the local variables will be also stored in this stack area. And once the thread will do its operation, and when it will come out from that method, then all those space occupied in a stack area by that thread will be get removed, right? So after that stack will be empty, and that empty stack will be destroyed by JVM, so just before terminating the thread. So when the thread will get terminated, so that stack area which is occupied by that particular thread will also get destroyed. So the data stored in a stack is available only for corresponding thread and not available for remaining thread. So it means that for a particular thread, a particular stack area will be kept, or it will be created by JVM. Once the thread work is done and the thread is terminated, then JVM will remove that stack area also, right? So this is about a stack area. Now let's discuss the PC register. So PC register is the fourth memory in JVM. So a separate PC register will be created at the time of a thread. So as the stack area is created by the JVM when the thread is created, in the same way a PC register will be also created by JVM when a thread is created, right? So what it contains? Basically, it contains the address of the current executing instruction. So the thread has to do some work, right? So thread has to call a certain method, or it has to perform some operations. So all those addresses of that current execution will be stored in a PC register. So once the executing instructions complete, automatically the PC register will be means like incremented to hold address for next instance. Okay, so let's say that a thread has to do means to call two methods. So first it will call the method A. So all those execution address will be stored in PC address register. And then again, when this execution will be done, now the thread has to call the second method. So that second method address execution will be also stored in PC register. And when the thread will will like terminated, so the PC register will also get like removed by the JVM, right? So let's discuss the last memory, that is a native method stack. So for every thread, JVM will be created a separate native method stack as the PC register and the stack area. So all native method invoked by thread will be stored in a corresponding native method stack, right? So these are the basically five memory. So for a JVM, uh, so for overall, like for every thread, the method area and the heap area are common, and the stack area, PC register, and native method stack. These memories are for particular thread only, and these have the lifeline till the thread is there. When the thread is terminated, then all these memory also get removed by the JVM, right? So I hope now you have a better understanding about the memory in JVM. Yeah, and now you can better explain to the interviewer when you will get this question that what is and the type of the memory in JVM. Now let's discuss the another question which I get. Yeah, that why we need a linked hash set when there is already we have the hash set and a tree set. Okay, so this is really a valid question, that already when we have a hash set and the tree set, then why the linked hash set come in picture? So in this, basically you have to reply in this way, that the hash set and the tree set classes are added in JDK 1.2 version, right? So hash set and the tree set are added in JDK 1.2 version, while the linked hash set was added to JDK version 1.4. It means that there must be some means there must be something which is not there in hash set and tree set. That's why the linked hash set come in picture in version 1.4 to remove to overcome or to fulfill the requirement which was not fulfilled by the hash set or tree set, right? So linked hash set came in picture in 1.4. So let's discuss this. So hash set provide constant time performance. So we know that the hash set provides a constant time performance for basic operations like adding, removing, and calling the content method to check that whether any element is present there or not. But the element are unordered. So headset has a good performance for adding an element, for removing, but the elements are unordered in an headset. In tree set, elements are naturally sorted, but there is increased cost associated with it. In tree set, we can get the elements in a sorted order, right? But it increases means like it increases the performance issue, right? So the linked hash set is added in JDK 1.5 to maintain the order of the element without increasing the increased cost. So actually, in hash set and tree set, we are not getting the option to be stored in an ordered way, right? So this was missing with the hash set and the tree set. So with the linked hash set, these like with the linked hash set, these like features are now overcome, and with the linked hash set, we are able to maintain the ordering of the element, right? So this is all about why the linked hash set come in picture in 1.5, although we have the hash set and the tree set, right? I hope you understand the point why it was necessary, because the hash set and the tree set were doing the work, but the order was not in an ordered way. It means it means that it was not storing the element in which we want in which in which like manner we were entering the element. Okay, so next question was like, can we override a static method? So no, like we cannot override the static method, because static methods are belong to class and not belong to object. So inheritance will not be applicable for the class member. So that's why we cannot override the static method, right? So what is the difference between the super key and the this key? So this was the next question. So basically the super is used to call the superclass constructor, whereas the this is used to call the same class constructor. Means, or it can be used to call the parameterized constructor of the same class, right? So this is the like difference between the super and this keyword. So the next question was like, what is a transient variable in Java and where we use it? So basically, a transient variable is used inside a serialization. So let's say that we have five members in a certain class, and you don't want a few members to get serialized, so you can mark that particular members as a transient. Okay, so it will not get. So here the transient variable cannot be serialized during the serialization process. So the transient variable state will not be serialized, and the state of the value will always be default after deserialization. And like let's say that if I have marked any member variable of a class with a transient, then at the time of deserialization, it will have a default value. Okay, if it is integer, then it will contain 0. Okay, if it is a string, then it will contain null, right? So this is about a transient variable. If you want to escape your like member variable to get serialized, then you can use a transient variable, and it is used inside your serialization. So yeah, so also you can get a question that what is serialization. So basically a serialization is a process by which we are saving the state of an object to transfer your object to some network or to the certain like server, right? So yeah, so like serialization is a process by which you save the state of an object, and it is used to transfer that particular object to the network, and also to the other servers, right? So this is about the serialization. So the next question I got, that in case there is a return at the end of the try block, so will it execute a finally block? So here maybe you can also get the question that what is a finally block. So basically this is from the exception handling. So here the finally block are the block which are used. It is used mainly to do some like operations by which we can close the resources which we have opened. Let's say that, for example, let's say an example, I want to some fetch some data from a file, and I want to store that data to the another file. So for that we have to open a file, right? And then yeah, and here you have to use input and output package. So the first of all you will open that file, and then you will copy that content of that file, and then you will paste that to the another file, right? So you will create another new file, and then you will paste it, right? So in this you are like opening the file, or also an example, if you are opening any like network, so these resources should get closed. So here so inside the finally block you can close this resource, right? So why you should include all these inside a finally block? The reason is that so like the finally block will always get executed. So if the exception comes or it does not comes, it will get executed, right? So yeah, so let's say that in try block you opened some file, and if the exceptions came, so then also it will end like then also it will execute the finally block, and your open file will get closed if you have written the logic to close that particular file, right? So finally block is used for doing the cleanup, or for like closing some resources if you have like already opened it, right? Because finally block always get executed. So here the question was that there is a like if there is a return statement inside a try block, So then also the finally block will execute. Yes. So here the answer will be yes. Finally block will always be execute even after writing return statement at the end of the try block, and it returns after executing the finally block, right? So this is the answer for this. So the next question was, so what is the difference between the array list and a linked list? So basically, the array list is used where if we have to do, like if we have to access some element from a collection, then we can go for the array list. Let's say that let's say that there is a huge like operations, or the number of operations are for accessing any element from a collection, then we can go for array list. The reason is that because accessing element are faster in array list, because it uses the index based, we can directly provide the index number and then we can use it. And also it implement a random access like interface, which make it much faster to access the element from the array list. And in linked list, like accessing element with the linked list is difficult. It is slow process to access any element which is in the middle or at the last. We need to iterate or navigate through the element one by one, and then we have to go to that particular index and then we can access it. So for the accessing any element, the array list is the best choice. Okay. And the linked list is like quite slow because we have to navigate to that particular node and then we can access that particular element from there. So array list, like insertion and deletion, is slow with the array list. Okay. So if we have the much operations like insertion and deletion, then we should not use the array list. We should go with the linked list. Okay. So array list insertion and deletion is slow with the array list because these operations array list need to adjust the index according to the deletion and insertion if you are performing on the middle index. Let's say that if you are adding some element in the array list, then the every element will get shifted. Okay. So it will bring your performance very low, right? But in linked list this is not the case. So you can insert and delete that particular node into the linked list if you have the address, right? Because in this, let's say that a particular node contained the address of the next node, right? If I want to add something, then only I have to store the next node address to the previous node. Okay. So in this way we can add, or we can delete that particular node from the middle. So it is like insertion and deletion is much faster in the linked list, because if you know the node, just change the pointer value. Okay. So yeah, so these are the 2 points where we can choose the array list. Yeah. So the question may be like to you that where we can choose array list and where we can choose linked list. So can you like define the scenario? Yeah. So for this, like this will be the best scenario where you can explain in a very deep manner that if we have this situation, then we can use array list. If we have this situation, then we can use linked list, right? Yeah. So next question I got was, yeah. So here I got some code and they asked me that will the finally block will execute, right? So here in my, like just before I explain you that every time the finally block uh, ex- will get execute. Okay. So you can read this like code, and then you can try to say that will finally block will execute or not. Okay. So you can like pause this lecture and you can solve this code. Okay. So yeah. So here the finally block will not execute. So there is an exception case. If if the code execute with system.exit1, then the finally block will not get execute. It will simply come out from the try block itself. It will not go to the finally block. So this is the only case where the finally block will not execute, because system.exit will try to exist from this try block and it will not call the finally block. So the answer will be no, the finally block will not get executed. The reason is that because inside the try block system.exit is like written, right? So the next question is that do you know about fail fast? So yeah, so basically a fail fast system is like immediate report of any failure when the problem occur, right? So fail fast system fails immediately in Java, and we can find this behavior with the iterator in case. So basically in the iterator, let's say that so let's say that we are iterating any collection with the iterator, and okay, so let's understand like this way. Let's say that there is one thread. So thread is trying to iterate certain collection one by one. And let's say that the another thread came, the second thread came and try to add some element to that particular collection. So in this the iterator will feel that the collection has now changed, so it will give, so yeah, so here it will fail and it will give the exception with the and with the exception like the concurrent modification exception, right? So this is the fail fast. So it come to the iterator. Let's say that if we are iterating any collection and another thread came and it's tried to modify that particular collection, then the iterator will fail and it will give the exception called the concurrent modification exception. And these come to the array list, to the hash map, to the hash set. So these are fail fast, right? So in the same way, he can ask you that do you know about fail safe? So there are some collections which are fail safe, and they are like if you are using the array list, then you can use a copyright array list. So these array lists are fail safe. Although if the modification are done by the another thread also, at that time also it will not fail. It will not give the this exception, right? In the same way if you're using the hash map, then you can go for a concurrent hash map. So concurrent hash map are fail safe, right? So but here is one catch, that if so catch is that inside the fail fast, so the iterator fails to iterate and give the exception when any thread tries to modify the collection in which the iterator is iterating. But if the iterator is itself try to remove any element, so you know that the iterator interface has the method so iterator has a method remove, so it is used to remove any element from that collection. So if the iterator tries to remove it by calling it remove method, then at that time the iterator will not fail. But if any third party thread is trying to modify that collection, then it will fail. Okay, so this is the catch. So yeah, so I hope you understand the point. Now the next question was that which is more faster, the concurrent hash map or hash table, right? So this is a very interesting question, that which is more faster. So concurrent hash map is faster, and it is introduced as an alternative of hash table in Java 5. So basically it is faster because it is designed in that way. So design of the concurrent hash map is that the concurrent hash map divides the whole map into different segments, and any lock, so it gives the lock to the particular segments. Let's say that a concurrent hash map has a 16 like segments or a 16 bucket, then the 16 lock will be there for every segment. So here the lock will be not to the particular object, like in a hash table. In hash table, the lock will be to the particular hash table object, but in concurrent hash map, the lock will be to the particular segment or particular bucket. It means that it means that we can do the update operation concurrently in a concurrent hash map. It means that in hash table, let's say that at one time a multiple thread cannot do the operation because a lock will be there, so the performance will be down in the hash table. But in concurrent hash map, a 16 so like a 16 like a segment is there, so it means a 16 thread can operate into a concurrent hash map, because the 16 lock will be there to the particular segments or to the particular bucket. It will be not to the particular object. So also the concurrent HashMap provide a lock-free read. So if you are reading from the concurrent HashMap, then there will be not any lock. So which is like not possible in a hash table. If we have to read, then also it will lock, and then a single thread can do the operation of reading from a hash table. But a multiple thread can read to the concurrent hash map. So that's why concurrent hash map is like more faster than a hash table. So in concurrent hash map, it's faster than hash table, especially when number of reading is much more uh, than the number of writes, right? So yeah, so guys, I hope you understand the point why concurrent hash map is much faster than hash table. Yeah, yeah. So like these are the questions asked to me in an TCS interview. So yeah, so all the best for your interview. Thank you and have a nice day.